So today we are going to start our parabola unit. I shouldn't say unit, our parabola section. Today we will get our introductory, so lots of vocab and figuring out what to do and when to do it. Tomorrow we'll put that into work. Graphing, hardcore tomorrow. I shouldn't say tomorrow. Thursday, we'll do that. Friday, then we'll work backwards. I'll give you the graph, and I want you to get the equation. Okay? So we'll do parabolas the rest of this week. Then next week, we'll do circles, Monday and Tuesday. And then Thursday of next week, we'll take a quiz. Because then Friday, you don't have school. You all don't have school on Friday the 14th. Okay? So, parabolas. The definition of a parabola is all points equidistant from a point called the focus and a line called the directrix. Okay? So there's a lot of big words in there. Okay? So let's start with the third one. Equidistant. What is equidistant? Equal distance, right? So the same length. Okay? So a parabola is a curve, a conic section, where any point that's on our parabola is the same distance from a point called the focus and a line called the directrix. Okay? Okay. At this point in time, you might as well stay.
But it's a 2-hour class, so I don't know when I'm paid for it.
I know.
I'll figure it
Okay.
out.
All right. So it looks kind of like this. So here's a point and a line. So this point would be called the focus. And this line would be called the directrix. Okay? And so our parabola is going to look like that. Because the focus needs to be inside the parabola and the directrix needs to be outside. So I can take any point on that parabola and the distance from there to there is equal to the distance from there to there. That's what the definition is saying. Okay? And we can move that red dot wherever we need it to be. Now I just quickly free drew this one. Okay? So clearly it's not. It's a little skewed to the right. Okay? But that's what it's going to look like. Okay? We're going to be developing it with more points so that you get a little bit more accurate. Okay? But we still have to find all of those. Okay? So the focus is inside the parabola, and it's also on what's called the axis of symmetry. It's that line. You've heard axis of symmetry before in Algebra 2. That's the line that cuts the parabola right in half. Okay? And the directrix is outside the parabola, and it's perpendicular to the axis of symmetry. Okay? Now, short of saying, giving you all this fluff stuff, okay, we're going to dive right into it. We're diving headfirst into the lake. Okay? So, the basic function, okay, the basic parabolic function, if you will, looks like either x squared equals 4 times p times y, or it looks like y squared equals 4 times p times x. Okay? Where p is very important. P is the distance from the vertex, which the vertex of our parabola, in this one, would be the origin. Okay. It's the distance from the vertex to the focus and it's the distance from the vertex to the directrix, because those points have to be equidistant from each other. Or I should say, the vertex needs to be, because the vertex is on the parabola, it needs to be equidistant from the focus and the directrix. Okay. So, looking at this particular function, one of the first things that you're going to determine, and it's actually going to be the first step that you're going to do with all of the graphs and all of the findings of the equations, is you're going to determine which way it opens. So since this parabola opens up, that's an x squared parabola. Okay? X squared parabolas open up or they open down. Y squared parabolas open left or right. Okay? So since this is an upward facing one, okay, the equation here, since this distance p is 4 times 4 is 16, so the equation here is x squared equals 16y. But we'll get more into that as we go on. Okay? So, here we go. Step number 1, which you're probably going to want to write down somewhere so that you have them handy and possibly even make it onto a note card somewhere. Step number 1 says you need to determine which way your parabola opens. So that if it's a U, part of an N, I don't know, a backward C or a C. Right? Alright? So you're going to have to determine that. And how you're going to do that is you're going to look at which variable is squared. So if it is x squared, again, it opens up or down. If it's y squared, it opens left or right. Okay. Then on top of that, okay, so that's the first part. The second part is you need to look at the 4p value. So if we have an x squared and the 4p value is positive, so that's the coefficient on the non-squared term. If that's positive, it's going to open up. If it's negative, it's going to open down. Because up is the positive direction, down is the negative direction.
So it's a y. If you had like a y squared, the negative would be on the left side.
So if it's a y squared one, the 4p value would be positive. Which way would it open?
The right.
To the right.
Okay.
And if it was negative, it would open to the left. Can't stress that enough. No matter what you're doing with a parabola, that's the first thing you determine. Because it's got to open one of those four ways. I am not mean and going to give you a parabola that opens like up and to the right kind of a deal. Because those are just nasty. Okay? They're doable, but they're nasty. Okay? Right? Because I think you almost got to do a parametric to do it. I haven't seen one since I think I saw one in college. It was ugly. That was one of those where I was my algebra 2 kids today. Just give it a look. Okay. Good to go on this slide. Okay. All right. So this is the function x minus 3 quantity squared equals negative 12 times the quantity y plus 1 that we are going to graph now for the remaining time. Okay? So that we're going to graph that right now. Okay? So the first thing that we need to do is we should go back and we should do step number 1. Which way does this parabola open? Based off of what we just had on the last slide. Which way does this parabola open? What's squared? X is squared, so that's up or down, right? Okay. And is that 4p term positive or negative? No, it's negative, so that means it opens which way, Owen? Down. Okay, it opens down because the x was squared. Okay, so this is an opening down parabola. Okay, so we keep that in mind. It's going to open down, 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 down. It's going to open down. Okay. All right. So that was step 1. We said x is squared, so it opens up or down. The 4p was negative, so it's going to open down. Step number 2 now. Step number 2 says we're going to identify our vertex because that's going to be our starting point. Okay? So, thinking back to what we know about vertices and equations, whenever we have a parenthesis, we think oppositely. Okay? So here I'm not thinking x equals negative 3. I'm thinking x equals 3, positive 3. I couldn't hear you. Wesley was coughing. Okay? Which was funny. Okay? But it was funny because every time he talked, he coughed. But I couldn't hear him twice. Okay? Alright? So that one's inside parentheses. What about the y? It's also in parentheses, so we also have to think oppositely. So I'm not thinking positive 1 there. I'm thinking negative 1. So my vertex here is at the point 3, comma, negative 1. With me so far? Okay. Let's take a pause for the cause here. You don't necessarily have to write these down, but find me those 2 vertices, if you will. Okay. Find me those 2 vertices. Just to make sure we got this thinking oppositely thing down. Top one, what are we thinking for the vertex? 10? What? 1 comma 0, is that what we're thinking? Okay. Because here I'm thinking oppositely, so that's x equals 1. And here, there's nothing else inside that parentheses, so that's y equals 0. So I'm thinking here the vertex is 1 comma 0. I like that. Second one, what are we thinking for the vertex? Why is it a little trickery? So what kind of a parabola is this one? A C or a backward C, right? Who's got the C's? Is that some fashion people? Don't they have a C? Chanel? Do they have like a C with a backward C? No, that's an up and down one. Coach or isn't it Coach?
No, my sister was almost.
Well, exactly. Yeah. I mean, somebody here's got to have one of them purses. Doesn't somebody have a C and a backward C? Chanel. All right. Well, anyways, so it's one of those, right? Okay. So here, this one, because it's attached to the Y, we're thinking -7. Here, we're thinking x is -2. So my vertex here is -2, comma, -7. Okay? It's not left to right. It's what's attached to that variable, x or y. Okay? We will have, in this unit, we will have left and right parabolas. So far, up to this point, you've only had up and down parabolas throughout your Algebra 1 and Algebra 2 careers. Okay? We are going to take it up another notch and go left and right. Okay? All right, so we're back into it. So now, actually, I got to go back here, and I got two. I think I just have to copy that for right now. You happy? Okay. The portal? Not till probably Thursday morning. Yeah, because our grades aren't due until Wednesday. Okay? So, step number 1 so far was, remember, it opened down. Step number 2 was our vertex was at the point 3, comma, -1. Okay? Step number 3 now says we need to identify the P value. Remember from before, our P values were x squared equals 4py or y squared equals 4px. Okay? So we need to pick out that P value. So I look at what's not the coefficient on the non-squared term. Okay? You want it in this form. You don't want it in all that other gobbledygook. You want it like this.
Okay.
Yeah. You don't want to square that out the left side and distribute out the other side. You want it just like this.
Okay.
Yep. Okay. So I'm looking here at 4p is -12. Okay. But really, because p is a distance, right? P was the distance from the vertex to the focus, or from the vertex to the directrix. So really, I've already handled the negative part of it. So I don't really care about this, that it's -12. Oh, that's a big one. Okay? I only care that the 4p is 12. Okay? Step 1 has already taken care of the opening down part. That's what the negative really signifies. Okay? So P then is what? P is 3. 4p is 12, so p is 3. Okay. So since p is 3, that then is the distance from my vertex to my focus, and from my vertex to my directrix. So now what I can do is, on my graph, since p is 3, and that's a distance, because I'm opening down, I'm going to go from my vertex down to get my focus. So I go down 1, 2, 3. So right there is my focus. Which would be at the point 3, comma, -4. Because this distance in here has to be P. I can also find my directrix, because the distance also has to be 1, 2, and 3. So my directrix is this line up there, because this distance is also P. So my directrix is the line y equals 2. With me so far? Okay. Breaking it down. Now I need to copy all of this. And then we go to the next line. And now I can paste all of that. Okay. So there we go with that. So I'm up to speed where you're at. Step number 4 says identify the width of our parabola. The width of our parabola is 4p wide through the focus. So our parabola is 4p wide through the focus, which means then that the focus is the midpoint of the width. Separate. Why won't you let me be separate? Don't be separate. Okay. So how wide is my parabola? Oops, maybe back on down. So my parabola is 4p wide, which is 12. So the focus is the midpoint, right? So how far left and how far right do I go then? 6. So I'm going to go 6 each way. Oops, that's a bad line. 1, 2, 3, 4, 5, 6.
Oh, so that's the
1, 2, 3, 4, 5, 6. Go ahead, Aaron.
Oh, so it's out from the not
From the, it's not from the vertex.
yeah.
It's from the focus. Okay. Now I've got 3 points on my parabola. So now what I can do is I can draw in oops, I missed my parabola. So I can draw in my parabola. Almost done. One more step to go. The last step that we have is we can finish this off by putting the axis of symmetry onto our graph. Okay. The axis of symmetry runs through the vertex and the focus. Okay. It's the line through the vertex and the focus. It's also perpendicular to the directrix. Okay. So my line that runs through the vertex and the focus is this line right there, which is the line X equals 3. Now, the reason that you have to go through those 5 steps, okay, and really, could you do the last step earlier? Because once you have the vertex, you have the axis of symmetry. Okay? So you could do that earlier if you want. That's fine. I'm not saying you got to do those in order every time. That's the order I'm going to do them in, but that's just me. I'm crazy like that. Okay? But on your homework problems that you're going to get, I'm going to ask you one for the graph, and then I'm going to ask you for the vertex, the directrix, the axis of symmetry, and the focus. And ask you for all of those points or lines. 2 of them are lines, 2 of them are points, 1 of them is a graph. Okay? So I'm going to ask you for 5 things on every problem. Okay? And you're going to have to fill all 5 of those in, hopefully correctly. Okay? Questions? I don't want to start another one yet. 1, because I didn't do it in the last class, and 2, kind of gave you a lot of information. Okay? Take some processing time. I get it. There's 51 days now. Okay? 51 days now. I get it. Okay? Alright? But so I'm going to stop here. Okay? And I'm not going to give you homework tonight. Okay? That just means you're going to have more homework than on Thursday. Okay? What's up?